Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 6, Lesson 2 on identifying cube root function. So we looked at the square root function, but now we're looking at the cube root function. Now, maybe we learned about the parent function of a square root, but not a cube root yet. I don't think I taught that yet. So let's see what that looks like. Well, first let's figure out the parent function. Well, it's almost like the square root one, except for its cube root, so you have a 3 here. Because, I mean, if you know, when you have x, pretty much it's a power of 1 and a coefficient of 1, but you don't write that. That's the same thing with the square root. You could write a 2 if you wanted to, but you don't need to. So that's what it will look like. So basically what this is saying is you take the cube root of x to find y. And basically you would cube y to find x. That's kind of what that means. And just like when we had the square root function, it was the same, like that. So let's look at points like we did with the other one. If you had 0 for x, you would have 0 for y. If you had 1 for x, you have 1 for y. If you had 2, I mean, like I said with the last video, you wouldn't get an even number, so let's not do that. How about if we had 2 for the y, like I said, you would cube it, and we would get 8. But you take the cube root of 8 to get 2. It's inverse functions. So we can see this actually can go negative. We have negative 1s, and we have negative 8, negative 2. So we can plot these points to see what this function looks like. I won't have them in there, but I can remember them off the top of my head. So we had negative 8, 2. We had negative 1, 0, 0, 1, 1, and then 8, 2. Okay, we can now do that. Not exact, but that's around what the function looks like. So for this function, it mostly just stays in these quadrants for the normal parent function. So this one can go in all directions. I forgot to say this for the last one, but the domain and range would be all real numbers for this one, but for the other one it would only be 0 to infinity. So that's what the cube root function looks like, and we'll look at transformations of cube roots and square roots in the next videos.